There's a tiny molecule athletes, biohackers, and Hollywood can't stop talking about. It's called a peptide. Some swear these heal injuries in days. Others call them an unregulated gamble. So who's actually right? From BPC 157 to Ozempic, let's break down what peptides really are, without the hype. By the end, you'll understand the science, the real risks, and which ones actually hold up. Quick note first, this is education, not medical advice. Okay, let's get into it. Let's begin with the basics. Peptides are simply short chains of amino acids linked together. Amino acids are the tiny building blocks of life. String a few together and you get a peptide. String hundreds together and you get a protein. So peptides are protein's smaller, simpler cousins. There are 20 common amino acids, and the order they're linked in decides what a peptide does. Change that order, and you change the message entirely. Sequence is everything. Your body makes thousands of these naturally. Insulin, for example, is a peptide. So what do peptides actually do? The simplest way to picture them is as messengers. Each one carries a specific instruction, like a tiny key shaped to fit exactly one lock. That lock is a receptor, a docking point on the surface of a cell. When the key fits, it delivers its message: grow, heal, release a hormone, or calm down. Because each message is so specific, peptides can be remarkably targeted in what they affect. That precision is the whole appeal. Hit one target and ideally leave the rest alone. It's also why peptides fascinate scientists, drug companies, and the wellness world alike. You might wonder how a peptide differs from the protein you eat in a meal. It mostly comes down to size. Fewer than about 50 amino acids, and we call it a peptide. Bigger than that, it's a protein. The line is a little fuzzy, but that's the rough idea. Smaller size means peptides are often easier for the body to absorb and put to use. It also means they usually act quickly, then break down and clear out of the body. Before the famous lab-made ones, remember your body is already full of natural peptides. They help control appetite, blood sugar, sleep, mood, immune defense, and tissue repair. Hormones like insulin, glucagon, and oxytocin are all peptides doing daily work. Lab-made peptides simply try to copy or boost these same natural signals. The goal is usually to nudge the body toward healing, recovery, or another specific effect. In other words, peptides aren't foreign chemicals. They're a language your body already speaks. To really understand peptides, it helps to look back about 100 years. In the 1920s, scientists discovered insulin, a peptide that transformed diabetes care. For the first time, a peptide became a life-saving medicine for millions of people. Decades later, chemists learned to build custom peptides piece by piece in the lab. That unlocked a flood of research into peptides for healing, hormones, and beyond. And it set the stage for today's wave of popular and controversial peptides. Now the one everyone asks about first, BPC 157. BPC stands for Body Protection Compound, a name that hints at its claimed purpose. It's a synthetic peptide based on a protective substance found naturally in the stomach. In animal studies, researchers explored it for healing tendons, ligaments, muscle, and gut lining. Some rat studies showed faster tissue repair, which sparked enormous online excitement. Fans now swear by it for stubborn injuries, sharing dramatic before and after stories. It's often injected near an injury or taken hoping to soothe the gut. But here's the catch. Almost all the evidence so far comes from animals, not humans. Large, careful human trials simply haven't been done yet. So much remains unknown. It's not approved as a medicine, and it's banned in competitive sports. The honest summary: genuinely promising, widely used, but still scientifically unproven in people. Closely related in reputation is TB500. It's a lab-made version of a natural healing peptide called thymosin beta-4. It's studied for recovery, flexibility, and helping tissue repair itself after damage. It may also play a role in helping new blood vessels form during healing. Athletes and gym goers often pair it with BPC 157, hoping the two work together. Like BPC 157 though, solid human evidence is thin and it's banned for athletes. Promising on paper, popular in practice, but still firmly in the experimental zone. Now for one with more real-world backing, GHK-Copper. It's a copper-binding peptide your own body produces naturally. Levels are high when you're young, but slowly drop as you age. In skincare, it's studied for boosting collagen, smoothing skin, and supporting wound healing. Unlike many peptides here, you'll actually find it in real products on store shelves. It's usually applied to the skin as a serum rather than injected. It's one of the more accepted, better studied peptides in the cosmetic world. This next pair is often used together: CJC 1295 and Ipamorelin. They belong to a group that encourages your body's own growth hormone. Instead of injecting hormones directly, they signal your body to release more of its own. People use them hoping for better recovery, more muscle, fat loss, and deeper sleep. Because they work with your natural rhythms, fans see them as a gentler approach. Ipamorelin is valued for being fairly selective, with fewer unwanted ripple effects. CJC 1295 is valued for lasting longer, so the signal stays active for hours. Still, they aren't approved for these uses, and long-term safety isn't well understood. Raising growth hormone also isn't automatically safe. More is not always better. Now the peptides making the biggest headlines of all, the GLP-1s. These are the weight loss and diabetes drugs you've heard of, like semaglutide and tirzepatide. Brand names include Ozempic, Wegovy, and Mounjaro, and they've exploded in popularity. They copy a gut hormone called GLP-1 that your body releases after eating. That hormone tells your brain you're full and helps steady your blood sugar. By stretching that signal out, these drugs reduce appetite for hours at a time. In trials, many people lost significant weight, which fueled their massive demand. Crucially, unlike most peptides here, these are actually approved and prescribed by doctors, but they still carry real side effects like nausea and digestive trouble. And stopping them often brings the appetite, and sometimes the weight, back. Their success proves peptides aren't fringe science. Some are mainstream, proven medicines. They've also become the gateway that introduced the whole world to peptides. Beyond the famous names, there's a long tail of lesser-known peptides. Take PT-141, studied for boosting sexual desire in both men and women. It works on the brain's desire pathways rather than on blood flow. A version of it is actually approved as a prescription medicine for low desire. It can cause flushing or nausea, and like all of these, deserves real caution. Then there's Melanotan, sometimes called the tanning peptide. It pushes the skin to produce more pigment, darkening your tan with less sun. That sounds appealing, but it's unapproved and sold on a murky gray market. It can cause nausea and may darken or change moles, which is a real concern. It's a clear example of a peptide where the risks deserve serious respect. Another group targets the brain, the so-called nootropic peptides. Selenk is studied for easing anxiety while keeping the mind clear. Cmax is explored for focus, memory, and protecting brain cells. Both were developed in Russia and are mostly used as nasal sprays. Outside a few countries, their human research remains limited and early. Interesting potential, but far from settled science. A few more deserve a quick mention for the curious. Ipamorelin is claimed to support healthy aging, though the evidence is preliminary. Thymosin alpha-1 is studied for supporting the immune system. Emotestkey is a tiny peptide tied to energy, metabolism, and exercise. Each is fascinating, and each is still mostly in the research stage. The pattern repeats. Big promise, small but growing piles of real evidence. Whenever you hear bold claims, ask the simple question, where is the human data? So where do all these peptides actually come from? Most are built in labs, one amino acid at a time, in a careful sequence. Reputable pharmaceutical makers follow strict standards for purity and consistency. But many sold online come from far less regulated, anonymous sources. Where a peptide is made can matter just as much as which peptide it is. Now, how do people actually take peptides? Most are delicate proteins that would simply break down if you swallowed them. Because of that, many are given as small injections just under the skin. Others come as nasal sprays, creams, or specially designed tablets. The newer weight loss peptides usually come as easy, pre-filled injection pens. The right method depends on the peptide and how it survives in the body. Many research peptides arrive as a dry powder that must be mixed first. Preparing them properly takes real care, and it's surprisingly easy to get wrong. Done carelessly, it's easy to get the dose wrong or introduce contamination. Once mixed, most need to be kept cold and used within a limited window. Poor storage can quietly ruin a peptide long before you'd ever notice. Dosing is where things get especially tricky and risky. There are no official dosing guidelines for most unapproved peptides. Instead, doses often spread by word of mouth through online communities. People also talk about cycling, using a peptide for a while, then taking a break. The idea is to limit side effects, but is based more on theory than proof. Guessing at doses of a powerful signaling molecule is exactly where danger creeps in. Which brings us to the part that matters most, safety. Even approved peptides like the GLP-1s carry real, documented side effects. Those can range from mild nausea to rarer but more serious problems. The bigger worry is the unapproved peptides sold as research chemicals. By definition, those aren't made or tested for use in humans. Allergic reactions, infections from poor technique, and unknown long-term effects are all real risks. Mixing several peptides at once multiplies the uncertainty even further. The simplest safety rule, the less we know, the more caution it deserves. Quality is the next hidden danger, and it's a big one. In the gray market, what's on the label often isn't what's in the vial. Independent testing has found products underdosed, overdosed, or contaminated. Some contain barely any of the peptide they claim to sell. Others may carry impurities that the buyer can never see. Without lab testing, you're essentially trusting a stranger with your health. Now to the legal side, which is genuinely confusing. A handful of peptides, like the GLP-1s, are fully approved prescription medicines. Many others are sold strictly for research purposes only, not for human use. That research-only label is often used as a loophole to sell them widely. Buying or using them for yourself can sit in a legal gray zone. For athletes, many peptides are outright banned by anti-doping agencies. The rules also vary widely from one country to the next. With so much confusion, a few stubborn myths are worth clearing up. Myth 1. Natural means safe. Plenty of natural molecules are powerful and risky. Myth 2. If it's sold online, it must be legal and tested. It often isn't. Myth 3. More is better. With signaling molecules, overdoing it can backfire. Myth 4. Anecdotes equal evidence. Stories are a starting point, not proof. Healthy skepticism is your best friend in the peptide world. So what does the future of peptides actually look like? Researchers are designing new peptides to last longer and target disease more precisely. Scientists are even using artificial intelligence to invent peptides that never existed before. We may see peptides for obesity, pain, brain health, and beyond. The proven approved branch of this field is likely to keep growing fast. The unregulated branch, meanwhile, will keep demanding real caution from everyone. Let's pull it all together with a few practical takeaways. First, peptides are real, powerful tools, not magic and not poison. Second, a few are proven medicines, while most are still experimental. Third, source and quality matter enormously, especially in the gray market. And fourth, if you're ever curious about trying one, talk to a real medical professional. Peptides sit at a genuinely exciting frontier of health and medicine. Approached with curiosity and care, they're a fascinating story worth following. Approached carelessly, they're a reminder that powerful tools demand respect. Thanks so much for watching this complete guide to peptides. And remember, this video is for education only, never medical advice.